This is the video for section 14.1 area. So we're going to talk a bit about area on a geoboard. So if we were in class, I have some geoboards with like little nails, and we can put rubber bands around them and make shapes. So we'll just be looking at pictures of them. But we can have any shape. Now, because each of those edges are a straight line, these are all polygons, right? So we're talking about the area of some polygon. And to figure out the area when it's on a geoboard, then we kind of look at the different, we break it up, okay? So the addition method says that if you have an area, then the sum of all the smaller areas is equal to the area of the big piece, right? So we're going to look at ways that we can break this up. So certainly, you know, there's this square right here, and it's 3 by 3, so that's got 9 in it. And here's another square. That's got 4. Here's a rectangle down here. It's got 3, and this is a 1. So now we have these little triangle pieces. You see that if we looked at this square right here, this 1 unit square, and putting it right down the diagonal, that's a half, right? So this is a 1/2. All these little half square triangles, these are all 1/2. All right, so I've got 9, 10, 11, 12, 13, 14, 15, 16, 17, plus there's 1 making these, right? And there's 1 with these 2, so that's plus 2, so it equals 19. Now, we could also look at this as the big square, right? So here we have, if we looked at this whole big square, it's 5 on each side, so that would be 25. And then I'm going to subtract off the ones that are not there, right? So this little piece right here is half of this square, and this square is 2 by 2, so it'd be 4, so half of it would be 2, so I got to subtract 2 off for this one. And here, well, I can count these 3, 1, 2, 3, so I got to count 3 off for that one. And then here's a 1/2, and here's a 1/2, so that would be another one off. Oh dear, I got a different answer. Did we add wrong? Did I miss one of them last time? 1, 2, 3, 4, 5, 6. No, I missed one. 2. Oh, okay. No. We're 19. Okay, I just can't subtract right in my head. So sorry. Okay, so anyway, those are kind of the methods that we use to figure these out. And here it kind of shows let me erase this, the different pieces as you could have seen them, which are a little bit different than the ones we used, right? But it doesn't matter. You can do them however you want to break it up. You just don't want anything to overlap. Okay, so I want you to look at this and construct, so the rectangle method, right? Construct a rectangle encompassing the entire figure and then subtract the areas of the unshaded region. So pause the video and see if you can do that. So those are the ones you should have been looking for, right? What's the area of A? Well, think about this area of A is half of this rectangle that has 6 in it. So A has the area of 3, right? What's the area of B? Well, it's half of this rectangle, which has 2 in it. So B is 1. And C is the same, right? D is 1, and E is the same as B and C. Okay, so I want you to try to draw some squares. I gave you a whole bunch of grids like this to make a square. I want to see how many different squares you can make, and just so you are thinking a little bit different, I want you to keep track of how many what the areas are of the different squares. So of course, you know that there's there's a square with the area of 1. So certainly 1 is one of our areas. And you could probably easily find 4, 9, 16, and 25, right? Those should be easy to find. But I want you to think also about this square. That's a square. All 4 sides are the same. They're the same length, and all the corners are right angles. So that's a square. But what's the area of that square? So if I think about each of these as a half square triangle, right? Half of that square, then that's a half, a half, a half, a half. There's 4 of them. So that is area of 2 square units. So pause the video for a minute and let's see how many of these you can find. So just in case you're getting stuck here, let's think about this as one side. Could you make it into a square? Remember that it has to be a right angle. So since I'm going up 1 over 2, I got to go do over 1 down 2 to get my right angle, right? So this would be a square. And I could do that with as many as I could fit on here. Over 3. So this would be a square. Now what's the area of that square? And could I fit one more? I think I probably could. If I go over 4, that would be a square. So what's the area of that square? So see if you can figure those out and see if there are any others that you can find. So let's see. So far we have, I know we found 3 there. We found 1, 2, 3, 4, 5, 6 there. But we didn't talk about the fact that we could have done all these on the diagonal that fit here. So there's that one where it goes 2 down the diagonal. And I think that's all we can do, because if I try to go 3, then it runs off the edge. So in this one I can only do 1 more. And could you figure out how much that one was? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Did you think of making our diagonal a little bit wider? So we did up only 1, but if I go up 2 and over 3, And that would be up 2 and down 3. That would be 1. I think that's the only other one besides the other. So that makes 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So there are 11 different ones. And let's just think for a minute about what these areas would be. We just need to break this up into pieces, right? So a bunch of triangles here. These triangles are all 4 the same size, and they are each half of this 6 rectangle, right? So that's 3, that's 3, that's 3, that's 3, and that's 1. So 13 square units. That would be 1. And you hopefully found out all the areas of the other ones. There should be an 8 and a 5. I think there was a 11. I can't remember. But you figured those out. But I just wanted you to think about these things from thinking about them in a little bit different way. Squares are not always right straight up and down, right? Okay, so when we're finding area, we're talking about square units. So on our geo board, we were talking about whatever that unit was. But in real life, we have units like centimeters and meters and decimeters and millimeters. And so here's just a little activity. I'd like you to draw or cut out. You might need a bigger piece of paper. Well, you for sure will need a big piece of paper for the square meter. But I want you to just see if you could find some scissors. Go find some scissors and cut out a square centimeter and cut out a square decimeter for sure. And just think for a minute about the difference between them. What's the difference between a centimeter and a decimeter? And what's the difference between a square centimeter and a square decimeter? So pause the video and go do that. So hopefully you notice, and I'm going to try to just draw a little bit here, but we think about each of these centimeters to decimeters is just a factor of 10, right? So there are 10 centimeters in a decimeter, but how many square centimeters are they in a square decimeter? Well, think about the fact that if that is our square 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Then there's 1 centimeter there's 10 centimeters in 1 decimeter, right? But once we look at a square one, it's huge, right? So there's this big old decimeter, and certainly, my gosh, it gets huge when we talk about meters. There's just this little tiny corner is the square centimeter, so it's a lot more than 10, right? In fact, there are 100 square centimeters in 1 square decimeter. And how many in a meter? Well, in a meter, if we were to break a meter into centimeters, right, there are 100. So there are 100 times 100 square centimeters, right? So if we're looking for the meter, it's 100 times 100, right? So here's kind of it broken down for you, right? So if we're looking at kilometers, right, there are 1,000,000 square meters. That's 1,000 times 1,000, right? There are 1,000,000 square meters in 1 square kilometer. That is so many, right? There are 10,000 square hectometers. There are 100 square decameters in a meter. Sorry, there are 100 square meters in 1 decameter. And then we go the other way, right? So the decimeters are smaller, and there's a meter is 1/100th. A square meter is 1/100th of a square decimeter. And a square meter is 1/10,000th. That's the one we were just talking about, right? 100 times 100. That's how many centimeters are in a square meter. How many square centimeters are in a square meter? All right, so knowing those, and you can certainly go back a little and refer to that screen, I want you to change 5 square centimeters to, that was supposed to have a spot there. Put a little empty spot there and a little empty spot there. It should show up on your page. I want to change 5 square centimeters to square millimeters, and 124 million square meters to square kilometers. Okay, so pause the video and go do those problems. So, we wanted to go, where are we going from? Square centimeters to square millimeters. So there are, I guess that's not going to help us. There are 10 millimeters in a centimeter. So that means that there are 100. So if we do this as square centimeters, we would need to multiply 1 square centimeter is 100 square millimeters. All right, so it's going to be 500. So this one would be 500. Now, you might know the regular ones and not know the squared ones. So let me show you how you would do that, just knowing what you know and not having to know all those squared relationships. In this one, I have 124 million meters squared, right? So what I'm going to do, I want to change it to kilometers, and I know that there are 1,000 meters in 1 kilometer. But I want kilometers squared, so I'm going to do it again. Okay, so now I got the squared meters, and these are my squared meters, right? So now I'm looking at squared centimeters. And so it will work just like that. When you multiply a kilometer times a kilometer, that's going to be a square kilometer. So I have 124. So for each of these 1,000, I'm going to cut off 3 of those zeros if I divide that in, and there's another one. So I'm left with 124 kilometers squared. All right, so here's some relationship between feet. We could have done the same activity with inches and feet. I sometimes do both of them, but didn't want you to do 2 different ones. I think the idea is clear that the number, when you go to squared units, the number is so much bigger, right? It's not like there are 12 inches in a foot. Well, there are 12 inches in a foot, but but when you go to squared feet, there are 144 inches, right? So here's a couple for you to try with the English units. So pause the video and see if you can find those relationships. Okay, so if we are looking for 400 meters, oh dear, let's skip A. Go ahead and skip A because I didn't talk about hectares. I was trying to avoid those and I forgot to delete that out of there. Well, let's just do B because it's giving it to us in square miles. So I have 400 yards on a side and it's square. So the area is going to be 400 yards times 400 yards, right? And I want to change this to square miles. So I don't actually know the number for miles, so I'm going to have to change these to feet first. And I have 3 feet in 1 yard. And I got to have 2 because I got square yards. So now I can cancel out my yards. And then I know that I have 5,280 feet in 1 mile. And I got to do it again. All right, so now we can just plug this in. So let's figure out the top first. 400 times 400 times 3 times 3. $1,440,000 5280 squared. And I'm going to divide that by 27878,400. So let's do that division. 4 divided by so I get that it is about 0.05 165, and we can stop whenever and round it off. All right. Okay, so I'm just going to run through quickly a few of the areas that you might be asked to find. You know all these, or you should know all these, right? The area of a square, it's just going to be the side times the side, right? The side squared. That's what the S stands for, side. A rectangle is just going to be your length times width. A parallelogram, so it's the base times the height, and the height has to be a perpendicular height, right? So this is showing that it could either be this height and this base, or it could be this height and this base. It really doesn't matter. So whichever one is the easiest to find. The area of a triangle is 1/2 the base times the height. And think about the fact that if you take the midpoint of that triangle side and you rotate it, you get the parallelogram with the base and the height. And so the triangle is half of that parallelogram. That's kind of one way to think about it. When you do the area of a kite, you can kind of think about it being with a rectangle, 1 and 2 together make a rectangle that is, well, the height is half of our one diagonal, right? And the other is the other diagonal when you do the whole thing. So it's 1/2 of the two diagonals multiplied together. The trapezoid, you can think of that also as two triangles. Here's your one triangle, right? There's your one triangle. And this other one is the base times the height. The height just happens to be out here, right? So it's 1/2 the one base times the height and 1/2 the other base times the height. And so this is how it combines. So when we're doing a polygon, we think of a regular polygon. The other ones we can't have a formula for, but a regular polygon. We can look at this A here is called the apothem. So it's the altitude going from the center to the edge of each of those triangles. And how many triangles are there? Well, there are n of them, however many sides there are, right? And so the base is the length of the side, which are all the same. There are n of them, so that's what this is right here, right? Which is also the perimeter. And A is the apothem, which is the height of each of those triangles. And so since they're all triangles, we're doing 1/2 base times height. So that is kind of the formula for the area of a polygon. You do not need to memorize all of these. I'll tell you the ones I want you to know will be triangle, rectangle, parallelogram, and circle. And the area of a circle it's kind of like that area of that regular polygon, except for as a circle has more and more, it's kind of like a polygon, a regular polygon with an infinite number, right? As the number of wedges gets bigger and bigger and bigger. So this is one thing that you might have to do, and we've done this sort of thing before when we did the circumference back when we were still in class, but we're actually making a ratio, or we make a fraction of whatever this degree is to the whole thing. And so that's what this is. That's the fraction of the theta to the whole 360, and we multiply that by the area of the whole circle. And that's how you find the area of a sector. And that's it for this section. I'll see you in class, and we can answer any questions you might have.